last topic for the night, which is super, super exciting, and I want you all to really take a moment. I did this with water. I didn't even use my Diet Coke tonight, which is huge. Okay, so topic 8 is, remember, I said at the beginning of this video, I'm many, many things. French ain't one of them. So this is a French name. It's Demoivre. Demoivre. I don't know. You probably say it much more eloquently if you actually have a French accent, but all the same, just understand what the theorem does. Don't get too hung up on the pronunciation of it. I will never criticize your pronunciation. Okay? Now, what this theorem does is it gives us a way to raise complex numbers that are in polar or exponential form to integer powers. Okay. Now, if we were going to try to raise complex numbers to integer powers in their rectangular format, it's not impossible. It's messy and it's tedious because you kind of have to envision, say that we had something like a plus bi. So that's kind of like just our OG complex number. And let's say we wanted to raise it to the sixth power. Well, that would be a plus bi times a plus bi times a plus bi times a plus bi times a plus bi, and finally times a plus bi. Not impossible, but we would have to FOIL, FOIL, and then we would get these nasty things that we then had to multiply. So we would have to multiply. And then we would have to multiply. And by the end of the day, we would have spent a really long amount of time doing this. We would have a gazillion different terms, a gazillion different little factors, a gazillion different little exponents, and this would get really nasty and really messy really quick. Okay. So again, not impossible, just not desirable at all. Okay. So when we have these complex numbers in polar or exponential form, we have a way around it, and it is this theorem. And I don't feel like saying his name again, okay? But anyway, so if z equals r times e to the I theta, so that's a complex number that is in exponential form. If we wanted to find a power of that, so that complex number raised to some power, so z to the n being some integer, n equals an integer power, then that would just be r to the n times e to the I times n theta. Okay, so basically raise r to the n power, multiply theta by n. Okay, and then just plug those numbers into that exponential form of a complex number. Now, on the flip side, if z equals r times cosine theta plus I times cosine theta, so that's going to be a complex number that is in polar form. If we wanted to find some integer power of that, so just like before, n equals an integer power, then what we do is we take r and we raise it to the n power, and then we take theta and we multiply it by whatever the exponent is. So raise r to the n power, my dog is probably going to bark, and multiply theta by n. She hears something outside. Okay. So we then just, all we have to do is take whatever r is, raise it to the n power, take whatever theta is, multiply it by n, and then plug those two values right back into the exponential form or the polar form of a complex number. Okay. So let's take a gander over here. We have example 16, which is our last one. Okay. And we have, let's call this z. Okay, so z equals the square root of 3 times cosine of pi over 18 plus I times sine of pi over 18. And we basically want to raise that whole thing to the sixth power. So we're looking for z to the sixth power. Okay, so what we need to do is figure out what r to the sixth power is, and then figure out what theta times 6 is. So let me rewrite that a little bit better. What we want to do is we want to find r to the n, so that is going to be r to the sixth, which is going to be the square root of 3 to the sixth power. We'll do a little work on that in just a minute. Then we want to find n times theta, which is really just 6 times theta, which is 6 times pi over 18. We'll do a little bit of work on that, okay? Now, first, we're actually going to do, I just noticed that I have rectangular form first and then polar form second. We actually need to do polar form first and then rectangular form second. So we'll actually start with part B and then go back and do part A. But for now, what I really want you to understand is something like that's fairly like it's going to be from way down in your past, but we have the root 3 to the sixth power. You could certainly cheat and put that into your calculator. I'm not going to get like too judgy about that. But please understand that root 3 is really the same thing as 3 to the 1/2 power. Okay? And then if we take that whole darn thing and raise it to the sixth power, we use what's called a power rule. So we would get 6, or we would get 6, good God. We would get 3 to the 1/2 times 6 power, which would just be 3 to the third power, which is really just 27. Okay, so the square root of 3 raised to the sixth power, that is just going to be 27. Okay, and then when it comes to multiplying our theta by whatever the exponent is, so in this case, n is 6, when we multiply theta by 6, we get 6 times pi over 18, which reduces very nicely to pi over 3. So that's the new value for theta and the new value for r that we're going to plug into these formulas, okay? Now is it going to let me do it? There we go. Let's go ahead. We're going to do polar form first because we're really going to need polar form before we get rectangular form. It's just going to be a boatload easier because basically we're just going to do polar form first, okay? So in polar form, you have to have your r, you have to have your theta, okay? So for polar form, we have, oh, there we go. We have z equals r times cosine of theta plus I times sine of theta. And remember, what we're going to do now is we're looking for z to the sixth power, which is r to the sixth power times cosine of 6 times theta plus I times sine of 6 times theta, which is really root 3 to the sixth times cosine of 6 times pi over 18 plus I times sine of 6 times pi over 18. And remember, we've already done the side work. We already know what r to the third and what theta times 6 is. So I think I said r to the third. We already know what the square root of r to the sixth power is, and we already know what 6 times pi over 18 is. So we just have to simplify here. So we could say z to the sixth equals 27 times cosine of pi over 3 plus I times sine of pi over 3. And that's it. Okay, so if you do your side work right off the jump, you can just plug those numbers kind of into the basic polar form of whatever number of like a complex number. If you feel more comfortable writing out, like the real formulas with the exponents, knock yourself out. Just either way you slice it, get the side work done and get your polar form, okay? So we have polar form right here. Let's go ahead just for the fun of it. Let's get exponential form. So if we were going to get exponential form, remember, z to the sixth would equal r to the sixth times e to the I times 6 times theta. Remember, n is 6 in this case. So we're just going to plug in r to the sixth, which we have already found, and 6 times theta, which we have already found. So we would get that z to the sixth equals 27 times e raised to the I times pi over 3. And that would be the exponential form, okay? So we really did need to do polar form first. Once we have polar form, then the regular rectangular form really comes from the polar form, okay? So essentially, to get rectangular form from polar form, you just kind of evaluate. So we would say, okay, we have z to the sixth equals 27 times cosine of pi over 3 plus I times sine of pi over 3. And to get rectangular form, we just want to like literally evaluate for pi over 3. So remember, if we're dealing with cosine and sine, pi over 3 is like right here. We have that cosine is a half and sine is root 3 over 2. So we're going to plug those values in. We're literally taking cosine of pi over 3 and sine of pi over 3. So we get 27 times, well, cosine of pi over 3 is 1/2. Sine of pi over 3 is root 3 over 2. So we're going to just distribute our 27. So we get 27 over 2 plus 27 root 3 over 2. And then I'm going to move my I to its rightful location. And that's it. So I should have done polar form as part A and then rectangular form as part B because you need polar form to get rectangular form. But alas, here we are. So it's been 75 hours. It's been 1,000 different examples, but we did it. We got through another super lengthy worksheet. So pat yourselves on the back, go grab a cold Diet Coke, watch some TV, or do some homework. That would be even better. And next time, let's see, we're going to start talking about vectors in the next section.